NENOMATICA, where mathematics meets YouTube excellence. We will rationalize a denominator step by step, exactly following the structure shown. First, here is our example and the problem statement in bold orange math. Step 1. We simplify each radical using the rule. The square root of a times b equals square root a times square root b. We will convert square root 32, square root 50, and square root 18 into multiples of square root 2. After simplifying, combine like terms to produce 6 times square root 2 in the denominator. Quick challenge. What will the whole fraction become when the denominator is replaced by 6 times square root 2? Step 2. Substitute the simplified denominator back into the fraction. We obtain 1 over 6 times square root 2. Step 3. Rationalize the denominator by multiplying by square root 2 over square root 2. This gives square root 2 divided by 6 times 2, and finally square root 2 over 12. We show the label example, as required, then the problem statement in bold orange math. After that, we proceed with clearly numbered steps. Rule box. Rationalizing ideas often start by revealing hidden structure. We show a tip box. Factor out a common expression. Step 1. Express the denominator in a factorized form. First, group the radicals into 2 parentheses. Next, rewrite each group as a product to reveal a common factor. Finally, factor out the common term to get a clean product. Now, we rewrite the original fraction using the factorized denominator. We'll show a quick tip box stating the factor form. Step 2. Rewrite the original fraction using the factorized denominator. To rationalize, multiply numerator and denominator by appropriate conjugates. We display the rule box. Use conjugates to create differences of squares. Step 3. Multiply numerator and denominator by the conjugate of each factor. We choose left conjugate, root 5 minus root 2, and right conjugate, open paren root 2 plus 1 close paren minus root 3. Now, we simplify the denominator using the difference of squares. Show rule box, a plus b times a minus b equals a squared minus b squared. Step 4. Simplify the denominator. First factor pair gives 5 minus 2 equals 3. Second pair gives open paren root 2 plus 1 close paren squared minus 3. Expand to 3 plus 2 root 2 minus 3 equals 2 root 2. Multiply to get 6 root 2 in the denominator. Having reduced the denominator, we write the simplified fraction. Small reminder rule, combine numerators over the new denominator. Step 5, write the simplified fraction. To remove the remaining radical from the denominator, multiply by root 2 over root 2. Show rule box for clearing a single radical factor. Step 6, multiply numerator and denominator by root 2. This yields the final rationalized form. Now present the final answer in a green box. It matches the algorithmic solution precisely. Welcome! In this lesson, we will rationalize a tricky denominator built from mixed radicals. Example: we will simplify the fraction shown in orange. Our goal is to reduce the denominator to a single simple value, then rationalize it so no radicals remain in the denominator. Here is the problem. Step 1. Rewrite each radical using prime powers so that all terms have the same index. We use the rule, the nth root of a to the m equals a to the m over n. Specifically, 6th root of 4 becomes cube root of 2, cube root of 16 becomes 2 times cube root of 2, and cube root of 54 becomes 3 times cube root of 2. Step 2. Substitute these into the denominator and combine like terms. After substitution, every term in the denominator is a multiple of cube root of 2. Add the coefficients carefully. 1 plus 10 minus 7 plus 4 minus 3 plus 4 minus 2 equals 7. So the entire denominator becomes 7 times cube root of 2. Step 3. Reduce the original fraction using this simplified denominator. 14 divided by 7 times cube root of 2 equals 2 over cube root of 2. Step 4. Rationalize the denominator of 2 over cube root of 2. Multiply by cube root of 2 squared over itself, so that the denominator becomes the cube root of 8, which equals 2. The fraction then simplifies beautifully to the cube root of 4. Final result. The original expression equals the cube root of 4. Display the problem in bold orange math. Step 1. Simplify each term in the denominator using exponent rules. Show the rule box for radicals and exponents. Now place the step title. We will convert 3 terms: the 5th root nested radical, the 30th root to the 9th power, and the 20th root of 8 squared. Step 2. Substitute the simplified forms back into the denominator and combine. Show a short reminder box. Place the step title. Now, write the denominator with the simplified pieces. Then, cancel identical positive and negative terms to reveal the cube root of 2. Step 3. Rationalize the denominator. Show the rationalization rule box. Then place the step title. Multiply numerator and denominator by the cube root of 2 squared. Simplify the denominator to 2. Finally, cancel the common factor and state the result, the cube root of 4. Welcome! In this lesson, we will rationalize a tricky denominator by carefully following the same algorithm and structure as the reference solution. First, let's display the example and the fraction we want to simplify. Step 1. Rewrite every term in the denominator using 6th roots. This normalization makes the algebraic structure visible. We use power rules: 2 times 6th root of 1/2 equals 6th root of 32, and so on. Watch the denominator change, term by term. Step 2. Group terms so a common binomial appears. We rearrange as pairs to reveal a shared factor. Notice the pattern. 6th root of 8 minus 1 shows up in every group. Step 3. Factor out the common binomial 6th root of 8 minus 1. We first factor numbers inside each pair, then extract the binomial. The denominator becomes a product of 2 simpler factors. Step 4. Replace 6th roots with simpler radicals. 6th root of 8 equals square root of 2. 6th root of 16 equals cube root of 4. 6th root of 4 equals cube root of 2. Substitute these to get an elegant factored denominator. Step 5. Rationalize. The full fraction is divided by this product. We will multiply top and bottom by square root of 2 plus 1 and cube root of 2 plus 1. Why? Because a plus 1 times a squared minus a plus 1 equals a cubed plus 1. Let it be the cube root of 2, then a cubed is 2, so the product becomes 3. Also, square root of 2 minus 1 times square root of 2 plus 1 becomes 1. Watch the denominator collapse to 3 and the numerator accumulate the 2 factors. We will solve the problem exactly in the structure shown. First, we display the example label and the problem in bold orange math text. Rule box: binomial expansion for cubes. Step 1. Express the denominator as s and set up the cube identity that will telescope. We let capital S be the entire denominator x plus the sum of squares from square root x plus 1 squared up to square root x plus 10 squared. Apply the identity to consecutive values starting at square root x. Step 2. Write a few consecutive instances and then sum them to telescope. Sums of consecutive integers. Step 3. Evaluate the bracketed sum. 11 copies of square root x plus the sum from 1 to 10 equals 55. Then isolate capital S plus the sum from 1 to 10 equals 55. Then isolate capital S. Replace the denominator by s. Step 4. The original expression equals 1 over s. Substitute our closed form. Conjugate multiplication. Step 5. Multiply numerator and denominator by the conjugate, x minus 10 square root x plus 35, to eliminate the radical. Then simplify the quadratic in the denominator. We will follow method 5 for rationalizing the denominator in a structured, step-by-step way. First, let us display the example and the problem statement. Step 1. Extract and restate the given proportionality. This is our starting rule. Step 2. Set each ratio equal to 1 over lambda. Then express alpha, beta, and gamma in terms of a, b, c, and lambda. Step 3. Rewrite the denominator using lambda. Group the first 3 radicals as capital South equals the square root of a plus the square root of b plus the square root of c. Then observe that the 3 new radicals equal square root of lambda times s. Factor s to get s times the quantity 1 plus square root of lambda. Quick challenge. What would you multiply by to rationalize the part 1 plus square root of lambda? Step 4. Express lambda as a ratio of sums. Since alpha equals a lambda and so on, the sum alpha plus beta plus gamma equals lambda times a plus b plus c. Therefore, lambda equals the sum of alpha, beta, gamma over the sum of plus b plus c. Step 5. Rationalize the factor 1 plus square root of lambda by multiplying top and bottom by square root of a plus b plus c. Let us display the example clearly. Then we will apply the rule boxes and step through the process. Rationalizing the denominator. The idea is multiply by 1 using a helpful form of 1. We will multiply numerator and denominator by the conjugate of the second factor in the denominator. This introduces a difference of squares in the denominator. Difference of squares. When we multiply a plus b by a minus b, we get a squared minus b squared. Apply this to the second factor of the denominator to eliminate the nested root. We obtain the denominator part as sum plus b plus c minus the sum alpha plus beta plus gamma. Rule box. Simplify the expression. After multiplying by the conjugate, we rewrite the entire fraction. The denominator becomes the product of the first factor and the difference of sums. Rule box. Multiply square roots. We simplify the numerator by distributing the leading square root. First, multiply the identical roots to get a plus b plus c. Then multiply by the negative root term to get negative square root of the product. Rule box. Final simplified expression. We place the simplified numerator over the simplified denominator. This is the fully rationalized form, with all math bold and the structure preserved. Example. We will solve a nested radical problem by following a clear, step-by-step algorithm. Problem. Given x greater than 0 and x not equal to 0, and the equation x plus 2 times the square root of x equals 2, find the value of x plus 4 divided by the square root of x. Quick challenge. Can you predict the very first algebraic move? Try to think of a substitution that simplifies the square root. Step 1. Substitution method. Let the square root of x equal u, with u strictly greater than 0. This turns the original equation, x plus 2 root x equals 2, into u squared plus 2u equals 2. Step 2. Completing the square. Add 1 to both sides to form a perfect square trinomial, giving u squared plus 2u plus 1 equals 3, which factors as the quantity u plus 1 squared equals 3. Step 3. Square root property. Taking square roots gives you plus 1 equals plus or minus square root of 3. Step 4. Solve for u and apply the condition u greater than 0. From u plus 1 equals square root 3, we get u equals square root 3 minus 1. From u plus 1 equals negative square root 3, we get u equals negative square root 3 minus 1, which is negative and therefore invalid. Keep u equals square root 3 minus 1. Step 5. Back substitution. Since u equals the square root of x, we have square root x equals square root 3 minus 1. Squaring both sides gives x equals the quantity square root 3 minus 1 squared, which simplifies to 4 minus 2 square root 3. Quick challenge. With x known, how would you evaluate x plus 4 divided by the square root of x? Think about rationalizing a denominator. Step 6. Substitute the value of x and set up the target expression. We write x plus 4 over root x as 4 minus 2 root 3 plus 4 over the square root of 4 minus 2 root 3. Step 7. Rationalize the denominator. Multiply numerator and denominator by square root of 4 plus 2 root 3. Inside the big square root in the denominator, we get 16 minus 12, which equals 4, so the fraction becomes 2 times square root of 4 plus 2 root 3. Step 8. Simplify the nested radical. Notice that the square of the quantity square root 3 plus 1 equals 4 plus 2 root 3. Therefore, the square root of 4 plus 2 root 3 equals square root 3 plus 1. Step 9. Final simplification. Replace the rationalized term with 2 times the quantity square root 3 plus 1. Then combine like terms. 4 minus 2 root 3 plus 2 root 3 plus 2 equals 6. Answer. The value of the expression is 6. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.